Good morning. Thank you for coming to my talk. So, as Jörg said, I'm a member of the FreeBSD and NetBSD team, and I was given an opportunity to give some workshops at various events in London and in England. And this is a talk about the various issues that we ended up addressing in NetBSD so that the workshops ran smoothly. So, a bit of background. There's a group of electronic engineers based around London who run various events. And back in 2013, they decided that they were going to run a workshop on Verilog for programming FPGA. We started with what were these introductory boards from Altera and using their proprietary closed source toolchain for learning Verilog. And this workshop was just an absolute disaster. It was over a weekend, and the first day we basically just spent the entire day trying to get the toolchain to install. The problem is that there is no open source alternative, and you're stuck with this toolchain, and you have to kind of get it working. They provide you with this 4 gigabyte download, which uncompresses and installs to about 13 gigabytes of multiple versions of Perl, Tickle, and various modules that go with it. So we spent best part of the day trying to get this to install. And then when we actually started doing the exercises and went to synthesize, we realized that some of us had actually installed the licensed version and not the free version, and you would have to go back and reinstall and start again. The reason I'm saying this story is because it made me realize that actually in some cases the tools are kind of mandated and you have no choice, whereas in our case we're an open source project and we can change things. Move forward a few years on. I was invited to give a talk about the BSD family of operating systems to the same group of engineers, basically, and why it would benefit them for running BSD on their hardware. At that event, I kind of took a more generic approach and represented all the BSDs. And about a month or so, a few months onwards, I was invited to actually come and do a workshop. And I've never run a workshop before, and my skills at teaching are non-existent, so I decided that I would actually just focus on one BSD and try to make that run smoothly. So I picked NetBSD to do that. Just as I forgot to switch slides. So the other thing that actually came out from that FPGA workshops is two of the guys went on to actually setting up an open source FPGA board with an FPGA toolchain, so you don't have to inflict this on other people ever again. Yeah. What's that?
If only the support of FPGA wasn't so limited.
Yes, this is true. So most of these people who are turning up are actually not interested in the software in itself, but what it can actually do for them. So my idea was to basically raise their expectations of what they should expect from an operating system, which we can do because we're a fairly mature project, fairly well documented, have fairly decent practices in place. And it was also very enlightening that things that that are of concern to us don't really hit the ball for them. So, mentioning that we don't have System D, just doesn't register. Whereas obviously it's a pain for most of us who have to suffer it. and I thought that I would basically, the angle that I would take it is, this is how you can save time trying to do your projects, and these tools will allow you to do that, and kind of develop that for them. So traditionally, if you want to kind of get involved with the BSDs, there's quite a steep learning curve in terms of the amount of text that you actually have to take in to become proficient in actually just how things are put together. And I didn't really want to kind of go down that line. I wanted to kind of find all the bits from a very high level that would allow me to demonstrate how they could save time and avoid digging into any of these technical details, because most probably they're not actually interested. I'd probably do a bad job at it, most likely as well. And you should be able to kind of do some things without actually having to resort to the internals. Interesting thing that's actually come up in the past couple of weeks is this new hashtag called Unqualified for Tech, where people are talking about, you know, the senior roles that they have without the academic backgrounds on Twitter, which is, it's nice to see. So you quickly realize that most of these folks have to kind of suffer really brittle tools to get their job done. Like one thing that was quite enlightening for me was the way that we generate our project files for our bootloader for Windows CE. We have this awk file which generates our Visual Studio configuration file, which you can load and you can build. If you make the slightest adjustment in 1 pixel from the user interface environment, Visual Studio will corrupt that project, and that's it. You can't make any progress. It's kind of, and obviously we don't have to suffer this, but I'm sure there's been many hours, man-hours lost by people trying to work with Visual Studio. Things like Brendan Gregg's shouting in the data center video, which, you know, showed the ability when you have really rich tools to, you know, shout at a bunch of JBODs, and through the instrumentation tools in your operating system, be able to see actually what impact that had. Most people don't have this in their day-to-day work. There's a researcher by the name of Brett Victor who gave this talk about rich tools, and the example that he was giving was when you're developing a game, going from trying to work out the correct setting for a value to set for your environment, you know, in relation to gravity, to being able to see that change dynamically in real time, to being able to project where you're going to go. So it goes from how did I end up here to what am I actually capable of to where can I actually end up going. And the last one, Brian Cantrill did a talk back in 2009 about the early days of dtrace and how that came about, where they had a Sun E10K that they'd sold to a customer, and it was misconfigured, and it would crash, and it would take another 45 minutes for the system to come back up again. So when you're actually trying to develop something or debug a problem, a 45-minute turnaround is quite a serious time sink. And there's enough examples of, you know, really bad tools that people have to kind of suffer, and that manifests in kind of really weird behavior, which I guess was kind of touched on in at the opening keynote. The amount of Windows users that, you know, live in fear of having to restart because, you know, suddenly your machine's going to go down into this long update cycle to shut down, and then there's going to be another 2 or 3 reboots again when your system comes back up. You know, not doing updates because you don't know what's going to actually happen when you update, and especially like in firmware. The system is so brittle that you can't actually explore any ideas, or like in the network world where redundancy is a licensed feature, you're really scared to change anything because if the system goes down, you can't do anything about it. And I think most of these things are just a non-issue for us in the BSD world, and especially in the NetBSD project. So as I said, focus on basically how NetBSD can make someone's life easier, and ignore the system internal details to keep it really high level, and just make sure that the process is really smooth so we can go through it without actually having to sidetrack. So these were the topics that I decided to kind of cover. Demonstrate that our system is fully documented, and well, not fully documented, but the documentation is available and easily browsable. Maybe in the era of GitHub, it's not so important, but demonstrate that the history in the source repository is readily available, and the FreeBSD project has the CSRG history that you can kind of go back and explore. The cross-compilation stuff that makes it really easy to do things without having to run the target environment locally. Actually explore the internals, explore the system with Lua, do some things with Rump, explore the simulation devices like the GPIO sim, and then I look at kind of tamper resistance with VaryExec. So we had this problem in that we generate images, but the images you can't log into on the network as standard because root doesn't have a password, and you can't log in. So at the moment, the requirement is that you need to have a serial adapter to go in and connect. The problem with that is for the Linux users, you kind of get sidetracked into installing a UUCP package so you can get CU, and have to kind of sidetrack into changing file system permissions, which kind of people get lost at. I'm not sure if this is still the case on the latest version of OS X, but in the older versions you would get unsigned kernel extensions, which would mean people would have to kind of fiddle around with their EFI settings and turn off signing. The nice thing is actually that one thing we do is we have multicast DNS enabled as standard for our ARM images. So discovery on the network is really easy, but we don't have means of logging in on the network yet. But that's my target, so that you'd end up just writing the image, plugging it into your device, booting it, and then SSHing in. So some of the kind of issues that were kind of evident immediately was when we came into doing like the cross-compilation stuff, the autoconf scripts for the various components that we pack were out of date. So the notion of 64-bit Windows running Segwin just wasn't a thing. The ARM image that we were generating wasn't actually bootable on the Beagle board that I was actually experimenting on. The GPIO driver wasn't actually working properly, which Paul Giotti helped me fix. And most of the ARM boards that we support has a generic kernel configuration, and everything is a derivative of that. There were some cases, specifically in the BeagleBone Black, that it was actually on a kernel configuration of its own, which meant that certain options weren't enabled, which I didn't actually find out until we came to the lesson, and somebody was actually having to do extra work that didn't need to be done because the Pi users had the relevant parts. And the last one, which is still yet unsolved, is broken U-boot scripts. Now, in U-boot, it's very much like a Linux project in terms of there's various support for various platforms, but the inconsistency is there in terms of TI have contributed a bunch of changes for adding an extra configuration file for your firmware, which one family of boards have picked up on and another family of boards do not have, which means that we can't actually have a consistent configuration file. And the reason this is a problem is that because we have two different steps, one ends up overriding the other in the order of execution. And it means that we're trying to execute a kernel that doesn't work on the BeagleBone. So since that stuff has started, since this has started, Mark made various changes to the Lua subsystem in NetBSD. He brought Lua up to date, and he had some things in his GitHub which I'm not sure have made it in yet. Jared McNeil made it very easy for us to ship U-boot. He's created packages, and it's trivial to add new images now, literally 2 or 3 lines in a make file, and we have new firmware. To do, I need to my idea is to basically create a kind of a worksheet so people can just work off easily. So that's still on the to-do list. Provide better Lua and rump examples. The reason I kind of wanted to do demonstrate the rump mechanism to the engineers was because there was a blog post by Antti about how he developed the Intel wireless driver and being able to pass through a device to the rump environment and develop that. The thing is that actually trying to demonstrate that you need to actually have quite a lot of context set up about the system internals, because you need to turn around and say you need the following subsystems to instantiate so that it works correctly, and that kind of goes off in a different tangent. So I'm trying to think of an easy example that would kind of work without having to, explain that, oh, you need to mount a file system, you'll need the VFS module and X, Y, and Z. As I said, implement a mechanism to add users for network access. The way that we provide our images, we have a DOS partition, and Jared had this idea of maybe we could just create a text file with a username and password, and then when the system boots up, that text file is read and the user is created so that it's available when the system is up. I haven't explored the options. Unify the U-boot script. So actually address this issue of having a single file which deals with all the boards that we support rather than having this split across multiple platforms. Mark Balmer created this Lua binding called Unix, which provides some of the common syscalls for the OS, and I'm guessing that was on the to-do list to make it in, but I'll maybe provide something around that to show that you can actually interact with the system without having to resort to writing C. And just from yesterday's Cherry's talk, perhaps maybe an ATF and a NETA talk example to show how you can do tests. But my only concern is that you'd kind of go off into dealing with QEMU. So my thanks go to Mark Balmer for doing the Lua subsystem, Paul Giotti for helping me with the bug fixes, Nick with making the images bootable on ARM, Jared for U-boot, and no thanks to Jared for U-boot.
I think it wasn't his fault entirely.
It's true, it's not his fault entirely. And the London Hackspace, where I kind of worked on most of this stuff, and Open Source Hardware User Group, where I got to present, run these workshops. And the next one is going to be next Saturday in Oxford at the Oxford Hackspace. So hopefully, yeah, this will kind of could continue running. And that's it. Any questions?
Volunteers? Questions?
Just a little suggestion. It may be easier to have people install PuTTY than CU.
That's true. Yes. Even on, but the CU is on for Linux.
Yes, but you can have
PuTTY on Linux.
PuTTY on Linux.
Oh, okay. I didn't realize. I thought it was still a Windows thing.
So anecdotally, I've heard from several people that they have like one or more ARM boards in the drawer, and it was just too frustrating to get, like NetBSD developers, to get anything booting on them. So they're sitting in a drawer. So I think you could get a lot more ARM users if there was a simple and working how-to for a couple of the most often used of these boards, I think.
One thing I should mention is the testament to the cross-compilation framework in NetBSD. It was basically the other thing that we address is that we're not inflicting a foreign environment to them as the offset. They're really sitting in their own environment that they're comfortable in, be it Mac OS or Linux. We've had a couple of people with Windows, but they've kind of had different problems. And yeah, it's really easy to get up and going. I didn't actually end up running a full release as part of the workshop because obviously varying speeds of laptops, you're not going to be able to turn a release around in a short time. But we can actually build a toolchain and build a ARM kernel in less than 15 minutes on a modern laptop, and that just works smoothly. For Windows 10, there's been different problems, and that's just been, one user hadn't been on the up-to-date builds, so it didn't have like the Linux subsystem, and another user had the Linux subsystem, but it was buggy. So when he started, uncompressing stuff, the system just crashed and rebooted.
The situation with the ARM boards is improving as well. One of the biggest issues was always finding the correct U-boot version for the board, and that's being worked on with the packages, and also the FDD support makes it easier to get a working kernel for your board without having to compile it yourself and things like that. So. But I fully agree that the documentation still needs a bit work to make it easier.
I think the U-boot documentation is it's so user hostile again.
One remark about the serial console. On Linux, on newer versions, you might have to disable modemd. So, or modem manager or whatever it is called. So basically, someone in the Pöttering land decided that all serial devices are obviously modems, and they always send some AT sequences to it to try to get it to talk back, and it's especially annoying if you're dealing with FPGAs you want to program, but it can also mess up any other use of serial consoles. So this is just a service announcement. Be warned.
Anyone else?
In that case, thank you very much.
Thank you.